Hi everyone, today Sally and I will introduce about our project. This is a project of medical image. In our project, we built models based on level 4, level 3, and level 2. We also created a concat model that combines level 2 and level 4. As a result, we discovered that as zooming level becomes smaller, the validation accuracy becomes higher. When we apply model concat, the regenerated heat map and the ground truth are the closest. For each level, we built models based on inception with 3 and created 3 different versions. First, let's talk about pre-processing slides. We had a general look at the slides and discovered that many slides have larger blank area. Also, some slides have some disturbance parts. For example, the projection of the cross-fixing clip of the microscope. It will affect the data and the validation accuracy of the model. For the second type, it has duplicate cells in one slide, and it can result in redundancy in training data. To solve this problem, we cut the borders accordingly before getting patches. We get it patch with 299 square shape and detect the tumor situation within the middle 128 square. For getting patches, there are much more normal patches than tumor patches. For some normal patches around the edge, they do not cover enough information. So we set a threshold for maintaining the normal patches according to pixel amounts. To be specific, we detected the least number of pixels for the tumor patches and set the minimum pixel of the normal patches more than that. In this project, we set the pixel number greater than 6,000 for level 2 and level 3, and set the pixel number more than 8,800 for level 4. It can help us get rid of the disturbing spots and normal patches that is without enough information, as is shown in figure 4. And these slides show some example patches of the 3 different levels. The next step is selecting patches for training and validation. This slide shows the amount of data we used for training the model in each level. In level 4, we only got 1,268 tumor patches and selected all of them because the dimensions for this level is smaller. And for normal patches, we randomly selected 2,000 of them. In level 3, we shuffled the dataset and randomly selected 4,000 tumor patches and 4,000 normal patches. In level 2 and the concat model, because the dimensions for level 2 is very big, so we only picked 3 slides with the most tumor cells and got patches from them. In the model for level 2, we randomly selected 2,000 normal patches. And for the concat model, we selected 2,085 pairs for level 4 patch and level 2 patch, which includes both normal patches and tumor patches.
Okay, so now I'm gonna talk about the training process. So for the first step, we basically just split our data set into 60% of training and the rest 40% for the validation. And then we're gonna apply 3 different models for each level. So first we can take a look at level 4. And the first model we've applied is a basic model that's the transfer learning without the fine tuning and also without the data augmentation. And after the 10 iterations, we have the validation accuracy to around 91%. And the second model is that we add the data augmentation to our basic model. And as a result, we can see the validation accuracy doesn't increase a lot. So it's almost the same as the previous one. And then for the third model, we're gonna add the fine tuning to our basic model with the data augmentation. And here we can see that even after the 30th iteration, our validation accuracy goes down a little bit towards 88%. So that's majorly might caused by the unstability of fine tuning. And now we're gonna take a look at the zoom level 3. Similarly, we apply the 3 models again. So the first is basic one. and its corresponding validation accuracy is around 89. And after we apply data augmentation to it, our validation accuracy is still kind of the same, not so much improvement. And then after we add the fine tuning to it, we are surprised to see that the validation accuracy boosts up towards 98%. However, we can also see from the validation accuracy and the validation loss curve that there are a lot of fluctuations back and forth. So that's may also caused by the fine tuning. It's not a really stable process. It's not a very stable process. And thirdly, we're gonna look through the Zoom level 2. Still the same, we apply the 3 models again. So for the basic one, we have 92% validation accuracy. And after we add data augmentation, it improved a little bit towards 94. And then after we add the fine tuning on the Zoom level 2, we have the validation accuracy to around 99%, almost a perfect one. But we still see a lot of bounce upside and down on the curve. That's also because of the instability of the fine tuning. So after the basic 3 models for 3 levels, we come up with another idea about the concatenation similar to the homework 4. So now I will switch to Tracy to talk more about it.
Yeah, finally, we applied model concatenate and concatenated the CNN for level 2 and level 4. The model structure is shown in this flow chart. We applied the following strategy for our concatenate model. For each patch in level 4, we get the corresponding level 2 patch inside the middle 128 square for each level 4 patch. And for each level 4 and level 2 pair, we only label the pair 1 when both patches are tumor. And this data frame that we use shows how we index the level 4 patches and level 2 patches and the corresponding label. And we trained the model for 10 epoch. From the result, we discovered that the validation accuracy for this model can reach almost 98%. Besides, the loss and the accuracy curves are very stable compared with the previous fine-tuning ones.
So lastly, I'm going to talk about the heat map, generated heat map of different levels and also the concatenation one. So let's look at the level 4, and we're going to see the resolution of heat map is kind of low compared to the ground truth. And now we move to the level 3. Compared to the level 4, we can clearly observe that the resolution gets higher. But still kind of low compared to the ground truth. And now let's look into level 2, and we can see the resolution gets higher and higher, and it's closer to the ground truth. And lastly is the concatenation one. We are really glad to see that the heat map resolution of concatenation, concatenating both level 2 and level 4 gets a really nice result. Is that it's almost the same as the ground truth, or more strictly speaking, it's kind of the closest one towards the resolution of ground truth. So lastly, we're gonna have a brief summary. Is that we find that for our project and strategy, fine-tuning might not be the best way, or might not be the most practical way. Is that because it generates a really unstable result, especially the unstable accuracy and the loss curves. However, now let's Tracy to talk more about a concatenation conclusion.
Yeah. Secondly, we discovered that although concatenate doesn't help a lot in accuracy, but it hugely improves the resolution of the regenerated heat map. Therefore, for our project, the concat model is the best choice. Okay, so this is about our project. Thank you for listening.